Muchas gracias, Pia. Buenos dias. This presentation provides an overview of the EKS dewatering technology. This innovative technology has been developed over the last 12 years and has been successfully field tested at scale under ambient conditions. The technology significantly reduces the economic and environmental liabilities posed by unconsolidated tailings. Next slide. The EKS technology is driven by two electrokinetic forces. The first is electroosmosis. Electroosmosis drags trapped water in the tailings to the surface. Specifically, the process acts on the bound water held by the electrical double layer that surrounds fine silt and clay particles. This bound water is not affected by hydraulic pressure, making these fine particles very difficult to dewater. The electroosmotic flow rate is dependent on the electric field strength. The stronger the electric field, the faster is the flow rate. The electric field strength also determines the maximum achievable final consolidation. The stronger the electric field, the higher is the achievable final consolidation state. The second electrokinetic force is electrophoresis. Electrophoresis acts on electrostatically charged fine particles suspended in a slurry. Electrophoresis pulls suspended particles out of suspension. The rate of particle settlement is also dependent on the electric field strength. By increasing the strength of the electric field, the settlement rate is increased. Both electrokinetic processes are controlled by regulating the applied power, which determines the strength of the electric field. The technology involves no moving parts or additives. During the dewatering process, electricity is the only input. The system is operated remotely. There are no on-site operators. Next slide. A full-scale field test was conducted in a built-for-purpose test cell. Next slide. The test cell was filled with 1,700 cubic meters of fine fluid tailings. This FFT had the consistency of milk and was composed almost exclusively of fine clay particles. The tailings had been in a tailings pond for more than 10 years and had undergone virtually no consolidation over that period. Next slide. The test cell was filled with this FFT, the electrode array was installed, and the system was powered up. Commissioning involved ensuring all electrical connections were okay, then flicking on the power switch. The system was operated flawlessly without any interruption for over 19 months and through 2 northern Canadian winters. The word operated is somewhat misleading. The process is operating in this picture, but there is little to see. There are no moving parts and everything occurs below the surface. Operating entails remotely tracking using in situ sensor data and adjusting the applied power as needed. Next slide. 1,100 cubic meters of water was released, comprising 80% of the total water initially in the tailings. The total volume was reduced by more than 60%, and the quality of the released water was better than the initial pore water chemistry. At the end of the field test, dewatering was not complete. Further dewatering was still occurring. The test was stopped only due to funding limitations, not for technical reasons. Next slide. At the end of the field test, much of the tailings was over 60% solids. Next slide. The dewatering energy for the field test was 15 kilowatt hours per cubic meter of water released. The EKS technology is significantly less costly to operate than other technology. The field test led to several significant innovations. These innovations will reduce the cost for future commercial installations. Capital costs vary with each application. However, significant economies of scale are available. Many of the system components can be reused for multiple applications. Next slide. The technical advantages of the EKS technology include: 1. The process does not incur maintenance or labor costs during its operation. As a result, operating costs are very low. The process can dewater tailings in situ as they are produced, greatly reducing material handling requirements. 3. The process dewaters tailings relatively rapidly and is most effective with the most difficult to dewater tailings. 4. The process can be used to produce a geotechnically stable cap on top of a tailings deposit. 5. There's a low risk of off-spec product. Process upsets are virtually non-existent. Power interruptions are no problem. There are no complicated or drawn-out system startup requirements. As well, by creating a uniform electric field, dewatering is uniform throughout the tailings. And finally, the EKS-DT process offers an environmentally attractive alternative to current tailings management technologies. Muchas gracias.